I'm Anil Kumar sharing with you some test questions on polynomials group factoring. We have 3 questions in this page. I'd like you to pause the video, answer these questions, and then look into my suggestions. Question number 1. Find the greatest common factor of each pair of terms. So we are given 2 sets. You need to find the greatest common factor. Question number 2. Determine the missing terms. Minus 12a cube b square equals to 4a square b times what? Question number 3. Factor each expression. Minus 25x square minus 10x. 2a cube minus a square plus a. C is 2x times x plus 4 minus 5 times x plus 4. D is 4abc minus 16ab minus c plus 4. Now you can actually pause the video, answer these questions, and then look into my suggestions. So I hope you must have got them all. After this, we'll take up 2 questions based on applications. Now let's answer these questions. Greatest common factor. So look at the numbers first, 15 and 10. What is the greatest common factor here? Well, number 5 is common to both 15 and 10. As far as the variables are concerned, ab square and a square b, a is common, and therefore 5a is the greatest common factor for a. Now let's look into b. Now this is slightly tricky. We have minus 2 to the power of 4, and here the number is 8. Now what is 2 to the power of 4 equals to? 2 to the power of 4 is 16, and therefore the greatest common factor between these two numbers is 8, right? You could also write minus 8, both can work for you. Okay, x square is common and also y is common. So 8x square y is the greatest common factor. So we found the GCF for both these questions, the greatest common factors. Now second question is, determine the missing terms. We have minus 12a cube b square. One bracket is 4a square b. As far as number is concerned, minus 12 divided by 4 is minus 3. So we get minus 3 here. Now variables, a cube, a square, 1a is missing, and b square b, 1b is missing. So that becomes the other factor. So in a way, we have factored. Okay. Question number 3. Factor each expression. So these are different types of examples. Here we have a binomial, then we have a trinomial, and this is partially factored, and here we have 4 different terms. Let us see how to factor them one by one. Minus 25x square minus 10x, we can take minus 5 common. Dividing minus 25 by minus 5 gives us 5, but we see also that x is also common. So actually, I should take minus 5x as a common factor, and then I get 5x for the first term, and here if I divide minus 10 by minus 5, I get plus 2. And dividing x by x is just 1. So the factor term is minus 5x times 5x plus 2. If you expand this, you get your original polynomial. So that is how we can check also. Part B. 2a cube minus a square plus a. The only common factor is a, and we are left with 2a square minus a plus 1, right? C. 2x times x plus 4 minus 5 times x plus 4. Now x plus 4 is a common factor, so we can write x plus 4 here, and then we are left with 2x from the first term and minus 5 from the second term. Now in this case we have 4 different terms. We could group them into groups of 2's and then factor. Okay, so let's group them in this fashion. In that case, what do you notice? From the first two terms, I can take 4ab common. I am left with c minus 16 divided by 4 is 4, c minus 4. In this case, if I take minus common, I get c minus 4. And now c minus 4 is a common factor. So taking c minus 4 as the common factor, we get 4ab from the first term and minus what? 1. So if there is nothing before it, it means 1 times the same thing. So that is how you could factor this. So I hope these questions give you a good insight to how to do group factoring for polynomials. Let me take a question here for you. You need to factor this one. We'll give similar to this. So let us say we have 3a times b minus a, and we have here plus a minus b. How will you factor this? So that is a question for you to do. So I hope you find this exercise useful. In the next video, I'm going to take 2 application questions for group factoring. Question number 4. The area of a trapezoid is 70x plus 10. Determine the height. So we are given a figure here where the two sides are 4x plus 1 and 3x, and the height is h, and we need to find what this height is. Question number 5. Show that 1 greater than the sum of squares of the, so there's a typing error, let me rewrite. Show that 1 greater than the sum of squares of any 3 consecutive integers is always divisible by 3. So you can rewrite this question. Show that 1 greater than the sum of squares of any 3 consecutive means the numbers which come together, right? So consecutive means numbers which come together is always divisible by 3. So try these questions and then look into my suggestions. Now we are given area of the trapezoid. What is the formula for area? Area of this trapezoid will be, we have to add these two sides, which is 4x plus 1 and 3x, and then we have to multiply with height and then divide by 2. So that is the area of this trapezoid. It could be written as 4 plus 3 is 7, so we get 7x plus 1 divided by 2 times height. So that becomes the area of a trapezoid. Now we are also given that the area of the trapezoid is 70x plus 10. Look at this number. So we are given area equals to 70x plus 10, and we need to find what height is. How are you going to do it? Well, let's factor. So this, you can factor 10 out. So if you factor 10, you get 7x plus 1. Now if you compare, we have 7x plus 1 divided by 2 times height. So if I have to write like this, we get height divided by 2 is 10, or I could write this as what? I could write this as 20 times 7x plus 1 divided by 2, right? So 20 divided by 2 is same as 10, right? But if you compare, you can get height as equals to 20. So we get height equals to 20. Do you see that part? So that is how you can find it. So once you compare, then this part is exactly same, and what remains is the height. So that is how you could do it. Alternate method could be, if you want to do direct from here, height divided by 2 is 10, so height is 20. Perfect. So either way, the correct answer is height equals to 20. Perfect. Now second question here is, show that 1 greater than sum of squares of any 3 consecutive integers. So when we are taking integers which are consecutive, we could take x plus 1. The third could be x plus 2. But look here, I could also take x minus 1 as my third integer. So let these be 3 integers which are consecutive, right? Since the difference is 1, they come together. Now we have to show that 1 greater than sum of squares of 3. So 1 greater than sum of squares means what? Let's try to write a statement. 1 greater than sum of squares. So sum of squares of these numbers will be x minus 1 whole square plus x square plus x plus 1 whole square, and 1 greater than means plus 1. So that becomes an expression for the given statement. Is that clear? Now we need to solve this. So we can expand and simplify. So if I expand, you remember the formulas. A minus b whole square is x squared minus 2ab, that is 2x plus 1. Here we get plus x squared. Here we get x squared plus 2x plus 1, and we already have plus 1 here. Now we could combine these terms. We get 3x squares, and we have minus 2x and 2x. They cancel out. It is 0. Plus we have plus 3, right? We got 3 ones here. Plus 3. Now in this case, I could factor out 3. So if I factor 3, I get x squared plus 1. Now we know it is a multiple of 3, right? So what you get here is that it is a multiple of 3. Therefore, divisible by 3. Do you understand? So that is how you could do it. Now we have used a couple of formulas here. Let me give you these formulas. We learned them earlier. One is a minus b whole square, which is equals to a square minus 2ab plus b square. Then we had a plus b whole square, which is a square plus 2ab plus b square, right? So I applied these two formulas to expand the two terms here with square, and then simplified and did group factoring to get the result. This is a very important question from test point of view. I hope you appreciate it. Now we have 4 examples. I would like you to copy these examples, factor, and then look into my suggestions. To begin with, I have done partial work. So this is also very interesting. We have done one step of factoring and we have to do further. We have 3 times b minus 2 minus 5 times 2 minus b. So when you look at it, you think as if there is nothing common, right? But there is. What is common? B minus 2 is common. Let's rewrite this. You will realize. So we have 3 times b minus 2. And if I take this minus inside, making this positive 5, I get b minus 2 here also. Do you understand? Minus 5 times 2 is negative 10, which I get here. And minus 5 times minus b is positive 5b. So they are exactly same. And now it is easy to factor. B minus 2 clearly is a common factor. And so we get b minus 2 plus 5 times b minus 2, which is 5 plus 3 we'll write here first. And then we could write this as 8 times b minus 2. Is that clear? So likewise, we could actually factor this particular expression. Now some of you could actually expand, simplify, and then also do it. But this is the way in which you can do it in minimum steps. At times, we can have a variable here which can make things difficult. Okay. So for you, what I'm trying to say is, I could have given a question like this. 3 times b minus 2 minus, let's say, x times 2 minus b, right? Now, you will understand how it changes, right? I like you to do this question as a test question. Okay. Now let's move on to the second question, which is part B. How do you factor 10a squared plus 5a minus 6ab minus 3b? Now in such questions, we need to make groups of 2's. So if I make groups of 2's, then what do I get? I get 5a common from the first 2. So that gives me 2a plus 1. And here I have 3b common, minus 3b if I take out, then I again get 2a plus 1. Now 2a plus 1 is common factor. It's good to write equal to, since every statement is equal to the previous one. So now 2a plus 1 is a common factor, and we get 5a minus 3b, and that is the factored form. You understand it. So this is the strategy which should be adopted where you are given 4 terms. So group them and then factor individually each group and then continue. Perfect. I'll provide you a link where we could have 6 terms, so we'll have 3 small groups. Okay. Now I'd like you to do these 2 questions on your own. You can pause the video, solve, and then look into my suggestions. Okay, let's continue. So here again, let's group them into 2 groups, and what you get. 4ab is common factor, right? You're left with c, and here you're left with minus 4. Here we can take minus as a common factor, we get c minus 4, and then c minus 4 is a common factor which results into 4ab minus 1, and that's how you factor it, correct? So now you realize why I took example A, which is kind of partially factored, right? So a step in between. Let's continue. Here we can again group. So first 2 we are grouping together, second 2 we are grouping again. In the first row, 5 is common number and a is common. So we get b minus 2. Here minus 3 and c is a common factor, we get b minus 2. Now we can take b minus 2 as a common factor, we get 5a minus 3c. You get the idea. So that is how we could actually factor these terms. I hope you find it interesting and useful. Feel free to write your comments and share your views. And if you have questions, post them. I'll be more than happy to answer your question at the earliest. Thanks for watching and all the best.